We do a lot of reporting with paper. A lot of paper goes over our desktops these days. We have a lot of PDF files that we get. Pretty much everything we do as far as NDT reporting is all on some sort of a PDF file or something like that. But what often happens is we get to a stage about through the 15th page of that document and we've actually lost track of what we're actually looking at. The relativity to the actual system is lost, if you like. So I'm going to talk a little bit today through a presentation actually, because I've actually got a very short time frame today, on what we call the digital twin, which is actually the concept of modelling a process plant and capturing that in a digital form. And then at the end of that, I'll talk briefly about our 3D reporting component to that. So just try and play this presentation and hopefully we'll get some sound coming through.
Digital twins at Applus. This movie is broken into...
Probably can't hear that, can you?
The first part of the process is digital twin capture. Total station.
I'll probably talk it through. So what he's doing here, he's actually creating a survey map of the area. This has actually been done down at the BP refinery. So they set some context points into survey points.
Survey practice. Laser scanning.
And then they set up a laser scanning system to actually capture the points in point form.
These laser point clouds later used in the reconstruction process for creating intelligent CAD models and operating photogrammetry models. Applus has many years of experience scanning as-built geometry using survey methods as well as laser scanning. Aerial photography.
We then use drones. Applus have a very large drone company based out of Adelaide. And we use the drones to actually capture aerial surveys. And one of the advantages of drones is that we can actually use GPS tracking. So we can actually do a drone survey of a building and actually track that GPS track and do exactly the same track next year and then the year after. So then you can actually overlay the information and look for differences between structures over time. The other thing is with a drone, we can actually look into services that can't normally be accessed. We're looking at a flare tower here. So normally a flare tower would be isolated to actually look at it. With the drone, the limitations are less. We've used the system not only for oil and gas infrastructure, but we do power lines, rail circuits, shipping ports, all sorts of assets as well.
Enabling remote visual inspection in any indoor environment. Helios prevents the need.
We can actually use the system for confined space entry. So we're actually going to take this drone inside a confined space and we can do an actual inspection inside. Now this is all capturing information as we go, which we'll talk about how we actually then reconstruct it into a model.
May also be performed using video footage such as that taken by the Helios drone. Terrestrial photography. Applus is able to design and build photographs.
One of the things we can do with our systems, we can generate additional photography devices to go into other areas. So that last example was in a confined space as well.
The next stage of the process is reconstruction.
Once we get all that information together with the photographs, we can actually reconstruct that into a three-dimensional model. So we use a process called photogrammetry, and we can overlay these models with CAD systems as well. That CAD model there has actually been generated from our 3D model.
These intelligent CAD models are backed by databases and typically involve development of catalogues using information provided by clients, such as...
We then overlay that data with P&ID data, and we can actually then look at the actual process piping, what they're doing, colour the circuits, all that sort of thing.
Photogrammetry. A good photogrammetry model involves the capture of large number of...
So the principle of photogrammetry is you're taking photos with a lot of overlap over a subject matter, and then once you get those photos back, we process it through software that actually positions where those original camera points were through triangulation, and that it determines the depth to where the actual structure is. That model's actually been recreated from the photogrammetry space.
The model quality depends on...
The little white markers on the sides of these are the actual camera positions. You can see how we've actually taken with the drone quite a lot of different photos to actually reconstruct the image.
Photographs and the amount of overlap.
There's your flare tower. So we're getting the concept that we're actually getting a lot of data now from these images and models, because you can actually take this into your desktop. You're not now having to actually be out in the field to look at it. It's a very useful technique, but it also means from that we can actually offer different viewing techniques as well. So this is within the, we've got our own Applus vision viewing, and you can see you can actually walk around this virtual site. In fact, we've got a virtual reality option. You can put the VR helmet on, and you can actually literally walk around through these plants and actually understand what's going on. So we're going to talk a bit about the viewing now. So we have an app called Applus Vision, and you can see he's using the virtual reality there. And you can actually navigate through the area using the virtual reality, which becomes a very good training tool. If you're talking about health and safety issues and things like that, you can use this as a tool for actually giving yourself familiarisation through a process plant. And we have different tools that we can use. So we've got the drones, we've got crawlers and walkers, and all sorts of techniques that we can use.
And photogrammetry models. The viewer also has the capability to recall one photo among hundreds or thousands of photos by clicking somewhere on the model. The model, or any of the photographs, may be tagged by a list provided by the client in Excel format. Ultimately, Applus sees Applus Vision as a...
So as you can see, there's a lot of detail within that space with the process plant, very useful tool. What I'm going to talk a bit about now is how we can use that for a failure analysis, because that's more my area, destructive testing and failure analysis. So we get a pipe spill that's come in from a corrosion problem. We can actually do the same thing. We can do photogrammetry on that, and it allows us to create a model in 3D space. We can zoom that around, we can look at different details. So that in itself is actually quite useful to give to a client, but it actually lacks a little bit of information, because we want to actually attach to that other things that we've actually done, like chemical analysis, or there may be some spectroscopy we do with the SEM or something. So here's an example of our current 3D model viewer on a section of pipe. And as you can see, we're rotating it around. We've got a corrosion defect, which will come up in a minute. And the little circles there are just points of interest. So as we rotate that around again, you'll see that there's a defect, and we can actually see chemical analysis. So now I've got the data for the chemical analysis in that point. It's giving you the context of what we're looking at still. Rotate it around, you can see the corrosion defect. I can click on that and give more information about the actual specifics about the macro images and things like that. And a little bit of detail can be added in there as well. We can also split the model, so we can actually have multiple models in there. So we've actually done a cutaway. You've probably seen the back's cutaway now. And now we can actually look at the inside of the pipe in detail and show some areas of interest in there. Then again, we can click on a point of interest, show the detail. and up comes some more macros, scanning electron microscopy images and whatnot. So it's keeping you with the context of what you're actually looking at the time. I think it's a much better way of actually looking at a report like this, and for an engineer and particularly people who aren't necessarily technically qualified, is a good way of actually looking at it.
This movie is broken into 3 parts. The first part of the process is digital twin capture.
So that's it, very quick. We've got a demo down the back in our display if anyone's interested later on to have a look at it. Most welcome to talk about it. We've got the digital twin demo as well.
Okay. Thank you very much, Paul.